video, we will discuss about longest happy string. So first, let's understand the question. A string S is called happy if it satisfies the following conditions. S only contains the letter A, B, C. S does not contain any of triple A, triple B or triple C as a substring. S contains at most A occurrences of letter A, at most B occurrences of letter B, and at most C occurrences of letter C. Given three integers A, B, C, return the longest possible happy string. If there are multiple longest happy strings, return any of them. If there is no such string, then return the empty string. So what they are saying is that in the input, we are given three integers, right? The three integers are A, B, and C. You need to create the longest happy string. Now, what are the conditions for a happy string? That your string, your answer string, should only contain A, B, or C. In that string, A, B, or C should not be present thrice as a substring, meaning A should not appear thrice together, or A should not appear together three times as a substring, and similar for B and C. Then your answer should have at most A number of A's, B number of B's, and C number of C's. And you have to create the longest possible string. So whatever longest possible string satisfies all these conditions, that will be your answer, right? So now they are asking us to create a longest possible string, right? So how can you create a longest string? When you will try to accommodate most of these characters, right? When you will try to utilize most of these characters, then you can create the longest possible string, right? So we will start with the character which is having the largest frequency, right? Why we are doing that? So let's suppose I start with C, right? Then what can be my possible string? So one can be C, C, and then I cannot take C again because it will violate this condition. So let's suppose I take A here, then we take C, C again, and then B, and then C, C. Then in this case, what is the length? The length is 8. Now let's suppose you started with A. Then in that case, you would have taken A, and you have utilized all the A's now. Now you are only left with B and C. Now let's suppose I took C. So I can take 2 times C. Then again, I have to take some another character because I cannot take C again because it will violate this condition. So I will take B, and then I can take C again. So it will be CC. Now in this case, what will be your length? 6. Now let's suppose I started with B, then you took CC again, and then A, and then CC again 6. So if you see, if we start with the character having the maximum frequency, only then we will be able to accommodate it as much as possible in the string, right? Here the C's count was given to us as 7. When we started with C, we were able to accommodate 6 C's in our string. But when we started with A and B, we were only able to accommodate 4 C's, right? So that is why at all the steps we will check that out of these three, which character is having the maximum frequency, and that we will take into account, right? So keeping this thing in mind, if you see here, I said I will take the one which is having the maximum frequency, right? So here, which is having the maximum frequency? C. So I will take C now. So C's count will become 6, right? Now can I take C again? Because again, the frequency of C is largest as compared to A and B. So I will take C again. But can I take it? Yes, I can, because there is only one C here. So I'll take it. So the count of C will become 5 now. Now again, C is having the largest frequency, but now I cannot take it. Why I cannot take it? Because I have already taken two C's together. If I will add one more C again here, then this will violate our this condition, right? So now we will move on to the other characters. Then we'll check that out of these two, which is having the maximum frequency, or we can say out of these three, which is the character which is having the second largest frequency. Now here both are having the same frequency, so we can choose any of them. So let's suppose we choose A. So we will add A here, and now the frequency will become 0. Now we are left with only these two. Now out of this, C is having the largest, so we'll take C. Can we write C here? Yes, we can, because it won't be violating our condition. So we will take C here. Now how did we check that we can take C here? We checked here we are having CA. So if we add C again here, then these three are not equals to triple C or triple A or triple B, right? So that's why we can take C here. So let's suppose our last two characters are like this, right? Then in this case, if you will see that whenever my last two characters both are C and C, then I cannot take C again in this case, right? Then coming to this case, let's suppose here A is there or B is there. In both the cases, I can take C here, right? So in this case, I can take. Then in this case, let's suppose here A is there or B is there. In both the cases, I can take C here, right? So in this case, I can take, and we have this. So in this case, we can have A or A, then B or B, or AB or BA, anything. So in all these cases, I can take C here, right? So in this case also, I can take. So what I need to check is that whenever I want to take any character, I will compare it with the last two characters in my string. If last two characters, both of them, are equal to this character which I am trying to add in my string, then in that case I cannot take that character. I will have to choose the other characters, the one which is having the second maximum frequency, right? And if both of them are not equals to this character, or only one of them or none of them is equals to this character, then in that case I can take it, right? So now, we are left with four C's, right? So now if you will see which one we'll take, C is having the largest frequency. Can we add C here? Last two characters are A and C. Yes, we can. So we will add C here. So now count will become 3. Then we see now C is again having the maximum frequency. But can we take C here? No, because the last two characters are also C, right? So in this case, we will take B. Because A is completed, we are only left with B. So we will take B here, and this will also become 0. Now we are only left with C, so we will check for this. Can we write C here? The last two characters are C and B, so yes, we can write. So this will become 2. Now again you will check, can we keep C here? Yes, the last two characters are B and C, so we can keep C. So now this will become 1. Now again you will check, now last two characters are C and C. So in that case, we cannot keep it. And we are not left with any other character. So that's why we will stop here, and this will be our answer. This will be our longest possible happy string, and its length is 8, right? So now, if you see here, at every step, what we are doing is that we are taking the character with maximum frequency, right? After we have taken it, we are comparing it with the last two characters, right? So in that case, you will have two scenarios. One is that whatever is your answer string that is not having two characters as of now, right? That means length of the length of answer is less than 2. In that case, you do not have the two characters to compare with this character, right? So you will simply take this character and add it to answer, right? So you will add it to answer and you will decrease its frequency, right? Whenever I will say decrease frequency, then that means we are decreasing the frequency by 1 always, right? Now the second case is that your answer's length is greater than or equals to 2. That means it is having at least two characters. Then in that case, you can compare them, right? So now in this also, you will have two cases. One is the case where the last two characters, both of them are equal to your character, which is having the maximum frequency, right? So last two characters are equal to your max character. Max character is the character having the maximum frequency. And the other case is that the last two characters are not equal to the max character, right? So now what you will do in these two cases? So when your last two characters are equal to the maximum character, then I said you need to find out the next character which is having the maximum frequency, right? So you find next character with maximum frequency. So now this is also having two cases, right? This is also having two cases. One is the case where you do not have any other character. You are only left with this character, right? In that case, what you will do? If you are having no other character, then in that case, what we'll do? We will stop, right? Because we cannot take this maximum character further, right? And the other case is that we have the character. Now, when we are having a next character with the maximum frequency, then what we'll do? We will add it to the string, right? And we will decrease its frequency, right? So these two cases are covered. Now coming to this case where the last two characters were not equal to the maximum character. So now what you will do is you will add it to the string. You will add what to the string? This, the character with the maximum frequency which we were taking into account from here, right? That you will add to the string and you will decrease its frequency. So if you will follow this approach, then you will be able to create the longest string, right? Now if you see, We wanted the character with maximum frequency at each step, and in some of the cases we want to find the next character with the maximum frequency, right? So how are we going to get this character? What data structure we will use for this? So we will create a max heap for this. We will create a max heap. This max heap will store two things, which will be the count and the character, right? So let's suppose A is 1. So in the count it will store 1, and in the character it will store A. Then let's suppose B is also 1. So it will store this pair. And for C, let's suppose it is 7. So it will store this, right? So this we will keep in our max heap. So like initially we will push all these three in our max heap. Before our iteration starts, we will push the frequencies of A, B, C in the max heap, right? Then whenever you are adding any character to your string and you are decreasing its frequency, then what you will do, that whatever was the frequency earlier, you will decrease it by 1, and then you will push it inside your max heap again, only if the count is greater than 0, right? Because if after you are doing frequency minus 1 the count becomes 0, then that means we cannot use that character further. So in that case we won't be pushing it in our max heap. So if the frequency minus 1 is greater than 0, only then we will push it in our max heap. So now let's do the code for it, so you will understand better. So first of all, we'll create a priority queue because we want to create the max heap. It will be of type pair, which will take an integer and a character. We will name it PQ. Now I said that we will store the frequencies of A, B, and C in our priority queue, right? So, and we will push only when the frequencies are greater than 0. So we'll check that if A is greater than 0, then in PQ, push the frequency of A and the character A. Then if B is greater than 0, then in PQ, push the count of B and character B. Then if C is greater than 0, then in PQ, push the count of C, right, and the character C, right? After this, we'll create an answer string, which will initially be empty. Then we will loop till our PQ is not empty. Now, why we are looping till our PQ is not empty? Because in the best case, you will be able to accommodate all A, B, and C's, right? So in that case, your priority queue will become empty. That is why we have taken this condition. So while our PQ is not empty, we will find the character with the maximum frequency, right, which will be present at the top. So that will give us the count and the character, right? So this will be PQ dot top, and then we will pop it out, right? Now we need to check that if the answer is having at least two characters, then are those last two characters equals to our current character or not? So we'll check that if answer dot length is greater than equals to 2 and answer's last character is equals to our current character, and answer's second last character is also equals to our current character, then in that case we cannot take this character and we will find the next character with the maximum frequency in our priority queue, right? So in that case also, first you need to check whether do we have any other character available or not. If our PQ is empty in this case, then that means we do not have any other character available to us, so we will simply break it here because we cannot accommodate this character further. So we will simply break. And if it is not, then we'll take this character. So this will give us the next character and its corresponding count, right? So it will be PQ dot top and we'll do PQ dot pop, right? Then what we'll do, we can take this character, right? So in our answer, we will add this character. And since we are adding it, then we will decrement its frequency by 1. Now after decrementing it, if it is still greater than 0, then we will push it back inside our priority queue. So this will be next count and next character, right? Now, if in case your answer was not having at least two characters, or last two characters were not equals to this current character, then that means we can take this character in our string. So we'll do answer plus equals to character, then we will decrement its frequency by 1, right? And in both the cases, we will check that if the count is still greater than 0, then push it back inside the queue, right? And at the end we can simply return the answer. So now let's run this. So our test cases are accepted. Now let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.